Next up, we're going to talk about the reflective property of parabola. Now, the main applications of parabolas involve their use as reflectors of sound, light, radio waves, and other electromagnetic waves. If you think about it, if you have Dish Network or DirecTV or any other sort of satellite service, you should know that it's basically a paraboloid of revolution. If we rotate the parabola in three-dimensional space about its axis, the parabola sweeps out a paraboloid of revolution. Now, if we place a signal source at the focus of a reflective paraboloid, the signal reflects off the surface in lines parallel to the axis of symmetry. Why do you think they put the receiver on the paraboloid on your dish receiver? Why do you think they put that little arm out to get that information? Now, what we're going to be doing in example 6, we're going to be studying a parabolic microphone. Now, every time that you need to create a parabolic equation or figure out where the focus is going to be, use an x squared equals 4py. That's the equation that we want to use. So please remember that on your homework. Now, on the sidelines of each of its televised football games, the FBTV network used a parabolic reflector with a microphone at the reflector's focus to capture the conversations among the players in the field. I'm sure you've seen them before. Large plastic parabolic microphones. If the parabolic reflector is 3 feet across and 1 feet deep, where should the microphone be placed? Well, here's what we're going to do. We know this distance is 3 feet. This distance is 1 feet. So that's why we have 1.5 and negative 1.5. So x squared will actually equal plus or minus 1.5 is equal to 4py. And y value is 1. Again, we're looking for our p value. Well, if we square this negative 1.5, this will be 2.25 is equal to 4p, which means p will equal 2.25 divided by 4, which is 0.5625 feet. Now we can also figure this out in inches. .25 divided by 4, that's where we get to 0.5625 feet. If we multiply that by 12, we'll get 6.75 inches. So the microphone should be placed .75 inches from the vertex. Now again, in B, the mirror of a flashlight is parabolic. Its diameter is 6 centimeters and its depth is 2 centimeters. So again, we're going to have a parabola that looks just like this, with this vertex right here. This will be the point 32. This will be the point negative 32. So we're going to use x squared equals 4py. That means plus or minus 3 squared is going to be equal to 4 times p times 2. That means p will equal 9/8 centimeters, or 1.125 centimeters. So the filament should be placed 1.125 centimeters from the vertex. There you have it again. Remember, even if it's put on its side, remember to use x squared equals 4py.